All right, so this is what happened. I was making a video and then I got a phone call that I had to take. I didn't get very far, so I'm just going to start over, but I'm not going to rewrite this. So anyhow, I bumped my camera holder. All right, so right here, so it says right here, show that this probability model is legitimate. And for the Frisco Garden Clubs, they had jalapenos, there was a freeze, and how many of our 4 plants did we have left? 40% had all of them. These people just need to cover their plants. But anyway, to show that it's a legitimate probability model, each probability is between 0 and 1, and the sum of all the probabilities equals to 1. That's you need to write that down. That'll be on your FRQ test. Okay, and then for mean and standard deviation, we plug in the calculator, stat edit, and already have them typed in there. Well, you can't really see. I guess we'll have to see if I can make this work. But there's all the numbers plugged in. And then stat calc 1, and remember we need frequency list to be L2. And then there's your mean, even though I know they use X bar, we don't write X bar. And then sigma 1.43, and that's the mean and standard deviation. All right, so then we write the mean and standard deviation, but then we have to backfill in the work, and it's this times this, this times this, and then you only have to show 2 steps and then plus ... All right, for the standard deviation, we still use 0 and 1, but with that 0, you need to subtract the mean. Square it to turn it to variance, multiply it times its probability, and then we add it to the next one. The value 1, okay, just like so, see 0 and 0 right there, 1 and 1 right there. 0.1, 0.1, and subtract the mean, square it, times its probability. So I still do 0 and 0.1, I still do 1 and 0.2, but I also subtract the mean and I square it, and then plus ... And make sure that that plus ... is all the way inside the square root sign. I know there's no way you have not heard me say that before. If it's close, I'll just say I better count it wrong just to be safe. Wouldn't want them, getting points that they don't deserve. So just to be safe, I'll just go ahead and count it wrong. If it looks, and I don't have the greatest eyesight, so you need to make sure it's clearly underneath that square root. All right, but then we have to interpret. So this one is, if I randomly select many, Frisco Garden Club members, the average, the average number of jalapeno plants that survived the freeze is about 2.4 plants. Actually, we don't even need the plants right here. Let's just get that out of there. We got plants right there. Oops, and also I'm not on this camera. Sorry, there we go. So if I do a large number of random selection of the things, the average is going to be about, and then whatever the mean is equal to. And for standard deviation is going to be, if I randomly select 1, Frisco Garden member, the number, let's say the number, that's better than the amount, the number of surviving jalapeno, I never couldn't spell this word right, from the freeze is typically off by 1.43 plants from the mean. And again, I don't need to say plants there because I have plants. Earlier in the sentence, 1.43 from the mean. And don't forget from the mean. All right. You will absolutely be doing that on your FRQ test. And I absolutely expect you to get it all correct. Minus the human error, of course, but there you go. All right. So the next one. Oh, yeah, I was going to skip this because I did it in my class, but what the heck? Let's just do it all. If somebody's absent, they might need this help. All right. So I tell you what, for any of these, I'm not going to read the question. I'm just going to go ahead and go through it. You can always pause it and read the question if you want. But on this one, I'm going to define two variables. Might as well make it so we can read it. So B is the length of a black cricket in New York City. And G is the length of a green cricket in New York City. And I'm going to do D is the difference between black minus green. Now in this problem, it does want us to find the probability that the green is bigger, but the mean of the black is larger than the mean of the green. I would like my mu of difference to be positive. So I'm going to, whatever one is bigger on average, I'm going to do that one minus the smaller average one. It does not have to be that way, but that's what I would have you do. So we can kind of think of this as step one. Defining the variables, establishing the order of subtraction. Then mu of D is going to be equal to mu of B, 4.2, minus mu of G, 3.9, which is 0.3 centimeters. Sigma D is going to be equal to the square root of, because remember we got to go turn them to variances by squaring them and then square root it back. But it's going to be 0.6 squared and then plus 1.1 squared. Now, nobody likes that, okay? But that's just something you're going to have to get used to. Oops. And then we're going to do the square root of 0.6 squared plus 1.1 squared. You notice everything's underneath that square root sign, which is good. 1.25 centimeters for the standard deviation. So step one, define and establish. Step two, nu, mu, and sigma. And then step three is the actual normal CDF part. So on this one, I want to find the probability that the difference is less than 0. Now, why less than 0? Is it says in the problem it wants the probability that a green cricket is bigger. So if green is bigger than the black cricket, this value is going to be negative. The cutoff will be 0, but I need it to be negative in order for the green cricket to be bigger. So that's normal CDF. I'm going to do lower is negative 100, upper is 0, mu of D, and you don't have to put mu of D. You can just do mu and sigma. I just trying to get in the habit of doing that correctly, so when it does matter, it'll be easy for us. And then we got 0.3 and 1.25. So you've got to find that nu, mu, and sigma, which is especially the sigma. That's the hard part in this question. So normal CDF, I go from negative. Now that one has negative infinity already in it. I'm just going to leave that one alone. And it shouldn't make a difference if you picked a reasonably large number, 0.405. All right, and then we answer the question in a sentence. There is about a 40.5% chance a randomly selected green cricket is larger than a randomly selected black cricket in New York City. Definitely cramming in there, but there it is. And there'll be a write-up just like this on your test also. So we need to definitely be ready. So here's another one, same basic type of problem. We have two different groups that are normally distributed. What's probably one's bigger than the other one is. And this is pretty much the game plan. Excuse me. All right. The weekly salary of full-time employee at Brahms is approximately normal with the mean of 474 or whatever standard deviation at Brahms. For Sonic, it's a little bit less, but more variable. What's the probability that a randomly selected Sonic employee makes more money than a Brahms? Okay, so on this one, again, Brahms makes more than Sonic. I'm going to do Brahms minus Sonic when I do my problem. So B is the full-time salary of a Brahms employee. And S is a full-time salary of a Sonic employee. And D is the difference, and I'm going to establish D as Brahms minus Sonic, so that my mu of B minus mu of S gives me a positive value, just like I did up here. And then they do want to know that what's probably that Sonic makes more. So again, I'm going to want the probability that the difference is less than 0, just like we did on this problem up here. All right, and so then I'm going to say, well, mu of D equals 474.39 minus 452. Okay, that's 420 something. 452.89. So that one's not, I like the other one better because I could do that one in my head, but the calculator takes care of all the problems with these messy numbers. So the average difference is $21.50, and the new sigma is going to be the 1574 squared plus, not minus, but plus 31.34 squared. So the square root of 15.74 squared plus 31.34 squared. All right, and then I want to know what's the probability that difference is less than 0. That's going to be normal CDF. Lower, negative. Better get a big number. Like salaries for those employees being off by $1,000 would be ridiculous. And then upper is 0. Mu of D is 2150. And sigma D is 35.07. And I might as well, let me finish typing this in. There's what I typed in. Again, you know what? I'm going to just change this so nobody thinks I'm lying to them. I hit enter, and I get 26.99. So 0.2699 or 0.267 would be fine. And I don't have enough space, so I'm going to be lazy, but there's about a 26.99 or 27% chance that a randomly selected Sonic employee makes more money than a randomly selected Brahms full-time employee. And here, I forgot that I had this. Hopefully, I'm double checking as we go. Hopefully I haven't messed anything up yet. But there's one I've got it written down on another piece of paper where I was a little bit better with my space. So there it is. And I'm going to turn the page, and I'm going to pay attention to it so don't mess up anything we got going on the rest of the way. All right. I'll hopefully keep this video under 40 minutes, but we'll see. At the Krusty Krab, the probability that a Krabby Patty is ordered with cheese is 74%. What's the probability? Exactly 6 of 8. So X equals a Krabby Patty ordered with cheese. X is binomial. N is equal to 8, and P is equal to 0.74. There's my state. Then my do step, the probability that X equals 6. That's equal to binomial or binom PDF. Trials 8, P 0.74, and X value is 6. Remember, PDF, we like that one. Not tons of thinking on that one. there is about a 31.08% chance my goodness, that exactly 6 of the next, and then I just kind of write it, next 8 Krabby Patties will be ordered with cheese. Definitely the most tedious part, but not the most difficult part. And as long as I got space, I'll do it. All right, what is the probability that it will take 3 ordered in order to get 1 with cheese? So X equals the number of Krabby Patties ordered before we get 1 with cheese. It will say ordered with cheese. And then X is binomial, or I'm sorry, no, it is not. It's until we get our first success, so that makes it geometric. Stupid. And P is equal to 0.74. The probability that X equals 3 is geomet PDF. And then it just asks for, it does not ask for trials, it asks for probability of success and X value, which we do the same thing, it's just gonna be 3 since it's PDF. So geometric PDF, 0.74. And I don't know, I can't remember anything but 3 and 0.05. There is about a 5% chance that the third Krabby Patty ordered will be the first with cheese. All right, so there's a binomial and geometric write-up about Mr. Krabs and SpongeBob and Squidward and all the crew down at the Krusty Krab. All right, here we go. Next one, number 5. The probability that a randomly selected 2015 Ford F-150 would make it to 200,000 miles before needing sending to the junkyard is 0.63. How many Ford F-150s would we need to randomly select before we would expect to get 1? That makes it to 200,000. So that's the expected value, and it's until we get the first one, so that makes it geometric. Let me just give me 1 second so I reach over here. That's the formula right there. The probability until I get 1 that does it, the expected value is 1 divided by whatever the probability of success is. 1.5, I expect to draw 1.587 trucks. Well, and you know what? Let's get this 2015 F-150 trucks. All right, that should be okay. What is the probability that at least 8, so at least 8, that's the greater than business, and it says 8 of 11, so that's binomial, and at least 8 means it's going to be 1 minus CDF. So X is, first we got to define X. X is a F-150, no, a 2015 F-150 that makes it to 200,000 miles before junked. X is binomial. N equals 11 and P equals 0.63. All right, what's the probability that X is greater than or equal to 8 equals 1 minus binom CDF? Trials is 11, P is 0.63, and X value. Since we're doing the 1 minus, it's what we don't want that we have to include in this one. We want 8 and bigger, so I don't want 7 and smaller. So binomial CDF, so I get 0.63. I'm sorry, no, trials is 11. Probability is 0.63, and then 7. Oh, I have a 0 in front of my biome. That's awesome. So I hit second enter and it give me the last thing, and I can just delete that 0. And sorry, I double tapped the enter, but it's 0.6285. So we'll go 0.629. There is about a 62.9% chance that at least 8 of the next 11 2015 F-150s will make it to 200,000 miles before being junked. Okay, there's another one, but binomial one, including they do have a geometric question for this expected value. All right, the probability that a lotto scratcher winner is 21%. You buy your grandma 25 tickets for her birthday. My grandma was always, she loved lottery tickets. That's where this question comes from. Why are these 25 tickets considered independent even though it is done without replacement? Because 25 is less than 10% of all of the lotto scratchers. Now, they never said that. So what we're actually going to do is come back and say we're going to assume 25 is. I think that is a very safe assumption. That would only be 250 of those lottery tickets. The lotto for every state, even the small states, they're going to make hundreds of thousands of tickets. So 25 is a good sample size. It is less than 10%, easily less than 10%. What is the probability that at least 5 of the tickets will be winners? So X equals a winning lotto scratcher. And if you want from grandma's 25, but X is the winning lotto scratcher, and then X is binomial because we have a set number of trials, because it says at least 5 and it's out of 25. N equals 25 and P equals 0.21. What is the probability that X will be at least 7, greater than or equal to 7? Greater than 1 minus binom CDF. Trials 25. P is 0.21 and X value is 6. I want 7 and bigger. I got to get rid of 6 and smaller. Binomial CDF 25.21 and 6. Now you could have done the 1 minus part, but it's going to be 1 minus 0.7. I'm just going to go 1 minus 0.74 equals 0.26. You could have typed it in one line and you would have went straight to the 0.26. There is about a 26% chance. It's not lowercase. Grandma wins at least 7 of the 25 lotto scratchers. All right. All right, so here we go. We're at 24 minutes and 30 seconds. So I'm going to go ahead and just finish out this. We really only need to do this one worksheet problem, and then this one will be quick. All right, so here we go. This is a multi-step problem. The College Board likes this format. They would probably not ask us to do part D, but this A, B, and C has been pretty common. So I'm going to go through this. And here we go. But the basic game plan is the same. They tell you what the old mu and sigma is, then they ask you to find a probability with that one, then they combine it and ask you to find a combined one, and then they ask you a binomial question. And then I added a geometric one just because, why not? All right, so the weight of a 50-pound bag of cement is normally distributed with the weight of 50.1. So they make the mean weight a little bit bigger to try to make sure more bags are not underweight. And a standard deviation of 0.15 pounds. What is the probability that a randomly selected bag weighs less than the advertised weight of 50? So X is the weight of a randomly selected bag of concrete. You know what? A randomly selected 50-pound bag of concrete. That doesn't, oh, and it says cement, not concrete. I'm not sure that even matters, but I don't know what is the same as what, so I'm just gonna write it the same. And then X is normal with 50.1 and 0.15 for the parameters of interest. Okay, and then the probability that X, it says weighs less. So even though it doesn't matter if I say less or equal to in the calculations, you must write it correctly there. So that's normal, CDF, lower I'm gonna go with 0, upper 50, mu of X and sigma X. But I don't know why I can never make this parentheses big enough. It's definitely irritates me. I guess not enough that I think about it. All right, and then we just plug it in, get the answer, write a sentence. .2525. So there is about a 25.3% chance that a 50-pound bag of cement weighs less than advertised. Okay. Now the next one says, what's the probability that 7 randomly selected bags weighs more than 351 pounds? All right, so now I need a new variable. Y is going to be the weight of 7 randomly selected bags. And I need a new variable, and since this is a continuation, I need it to not be X, not X. This is what X is, this is something else. Y is normal, okay, or you know what, I'm gonna write it with the abbreviation. But we need to find the new mu and sigma, okay? So mu of Y is equal to 7 times 50.1. Mu is always nice. Mu is always exactly what you think it should be. We like mu. 350.7. Sigma of Y, not so great. So what we're going to do is we're going to take that 0.15 and we're going to square it, okay? And then we're going to add times itself 7 times, but I'm not going to write that. So I'm going to do times 7. And also I don't want to type that in my calculator either. So the square root of 0.15 squared and then times 7. 0.39, we'll call it 397. So now it's normally distributed with my parameters of interest. I've got my new mu and sigma, and I need to state that. Okay, and then the probability that Y is, it says weighs more than, so Y is greater than 351. And that's normal CDF. Lower is going to be 351. Upper, some ridiculously large number, 1,000 is definitely ridiculous. And then mu of Y, sigma Y, and that's 350.7 and 0.397. I think it's a little tedious on the numbers, but you'll be all right. And there's what I plug in. And I get 0.22, 0.225. there is about a 22.5% chance that 7 randomly selected bags of concrete weighs more than 351 pounds. All right, so there's the old mu and sigma problem, then a new mu and sigma problem, and getting the new mu and sigma is going to be probably the hardest part because the rest of that's pretty easy. Then it says, what's the probability that 4 of the next 10 bags will weigh less than advertised? So X is the number, you know what? X is a 50-pound bag of cement that weighs less than advertised. Let me get this. And then X is binomial with P equal to and N equal to. N is 10 for the next ones. P, the probability that any one bag was less than advertised was 25. So we actually use the answer for part A and part C. Now, if you screw this one up, but then do this step right, you still get full credit. So don't worry about it. But they will do that where you use the answer in a previous problem to get the part of the work for another one. And then the probability that X, now at most 4, that means less than or equal to 4. So that's going to be equal to, binom CDF trials 10, P 0.2525. And X value is going to be 4 because I want 4 and 3 and 2 and 1 and 0. .9189. And then, you know what, I'm going to be lazy because I really want to try to squeeze this in under a certain amount of time. So there it is. 91.89% of chance you get at most 4 of the next 10 bags will be more than advertised. What is the probability that it will take less than 6 bags to get the first one that's not advertised? So on this one, oh, you know what? I can't believe I just did this. We need a new variable. So I will do, let's just do Z. And I always make my Z's with a little line through it so it doesn't look like a 2. And then for the next one, I don't know, I'm just going to make it W. W, X, Y, Z. It doesn't matter. You can use any letter you want. I'm just going to go with this. This is the number of trials. No, not the number of trials. The number of 50-pound bags. Trials is the general form, but we need to do context. The number of 50-pound bags I check until I get the first that weighs less than advertised. Or, you could say weighs less than 50 pounds. W is geometric. And P is equal to 0.2525. Still using that same decimal from step A. All right, so then the probability that W, it says less than 6. So that's going to be geometric or geomet CDF. Now, I don't want 6. It says less than 6, so I want 5. So X value is 5. P is 0.2525, and that's all you do. There is no trials. I kind of left myself space there, but we're not going to do anything with that. So geometric CDF, P is 0.2525, X value is 5, and it gives me my answer 0.766 or 67. Let's round it to there. And there's about a 76.7% chance that it'll take less than 6 bags before I get my first 50-pound bag that weighs less than advertised. All right, the next one, this is just a conversion problem, and we're just slipping this in here. I don't even know if this is on the test, but the height of FID basketball players has a mean of 6.4 feet with a standard deviation of 0.2 feet. Then it says give the mean standard deviation of inches. So this is the one where I'm altering all the data. I'm not combining 12 things together or 12 players together. I'm converting data by doing a transformation. And when I do this, multiplying affects both the mean and standard deviation. Adding only affects the mean, the center, or the mean in this case. Okay, the spread is not affected by adding, but they're not having us add here. All they're doing is they're going from feet to inches, and we do that with both of them. I don't have to do anything weird because, again, I'm changing the data, not combining different problems together. So 76.8 inches is the mean, and I'm just going to call that E of X. And then sigma X equals 0.2 times 12, 2.4 inches. All right, so that's my menu. And also, remember, we could have also called this mu of X as well. And then down here it says, find the probability of randomly selected basketball players shorter than 50 or 73 inches. So X is the height of a FISD basketball player. X is normal with the mean of 76.8 and a standard deviation of 2.4, nu, mu, and sigma. And then probability that X is less than 73.2 is normal CDF. Lower, so we go to 0. Boy, sorry, that 73, it's really messy. The lower is 0, the upper is 73.2, mu of X. And I can go back to X, by the way, since this is a new problem, the variables are reset on each problem. But if it's a continuation, you need a different variable. Mu of X and sigma X is 76.8 and 2.4 for the standard deviation. There's what it looks like in the calculator. And the answer is 0.0668, and answer the question in a sentence. But I'm done. I'm going to be lazy because I can, and also this is going to keep it under 40 minutes. But there's about a 6.68% chance that a randomly selected FISD basketball player is shorter than 73.2 inches. All right. If you went through that whole thing, that's a lot of FRQ questions on this that are going to be on your tests. All right, I'm done. And I'm done.